In this lecture, I would like to follow on previous speakers with a slightly different but very complementary perspective, how we can tackle with political biases. But now I will talk about algorithmic auditing of recommender systems. So I would like to start with a motivation. Usually, you know it, when we want to examine properties of social media AI algorithms, it is a really tough task. The main reason is that we cannot see inside these AI algorithms because they are black boxes for us. So we don't see their inner workings, how they are implementing, because this is typically like a business secret of social media networks. So there is a need for external independent oversight, and this kind of oversight can be provided by external independent algorithmic audits. And this kind of audits work as follows. So the basic concept is that we can somehow simulate interactions with social media AI algorithms, like we simulate content visits, we can watch videos at YouTube, etc. And at the same time, we observe how this black box actually responds to us. So we collect recommended items, search results, etc. And since these interactions, of simulating these interactions and collecting responses is quite time consuming, we usually use bots or human agents, so some kind of crowdsourced workers that can do this for us. This kind of external algorithmic audits have been recently recognized not only in the research works, but also in EU legislation, especially in the Digital Service Act. So it's something that we probably will encounter much more in future. So let's go deeper into this concept of these external algorithmic audits. So we typically start with audit questions. So we can ask, for example, how a recommendation algorithm distribute political ads among users. And by proceeding from this audit question, we create so-called audit scenarios. These audit scenarios consist of user profiles. So we can say that we will simulate a behavior of a user with some particular age and with some particular interaction history that is somehow like determining his or her political biases or ideology, etc. And audit scenarios also define user actions that need to be done during the audit. So let's say that we want such user to watch a sequence of videos, to perform some search queries in a search engine, etc. And finally, like we perform the audit itself by bots, by execution and simulation, these interactions and observing responses. And at the end, we have some audit report that actually like determines some characteristics of audited social media AI algorithm. The one typical thing for current audits is that they heavily rely on human experts. So typically these scenarios are created by human experts, by researchers, and also a part of this evaluation is still done mostly by human experts. So this kind of algorithmic audits have like a quite broad spectrum how they can be used for many things. So from the first perspective, it can be used to audit different phenomena. Typically, they are used to analyze filter bubbles creation or how AI-based social media algorithms can spread this information. What are their internal biases? From a second perspective, these external algorithmic audits can be used to audit search engines, recommender system, advertisement systems, or whatever what is based somehow some kind of personalization that makes a personalized experience for users. And in the third perspective, we can in this way audit practically any kind of social media network, search engines, or whatever kind of online personalized system. In the next few slides, I will particularly focus on political biases, but you can see that the coverage of these external algorithmic audits is much broader. So this research area is a relatively new one, with the first works emerging only 4 or 5 years ago, but still in this short time, it underwent quite a heavy development, and we will see it on 4 selected works I will now mention. So at the very beginning in 2019, one of the first works actually focused on search engine, particularly Google News, and just 2 users and a very small search terms actually were used to study how pro and anti-migration user history can influence what is like recommended or showed to user in Google News. Just 2 years ago, there was a work on YouTube that was much bigger, and in this case, like for various political topics, the audit actually examined popularity, topic, and emotional content that is recommended to users. Just last year, there is another work that started to audit not one system, but multiple of them. So it was audit of Facebook, Google, and TikTok at the same time. And you can see that the scope of audit is much bigger than it was before. So in this case, there was like a huge number of content that was observed. And in this case, it was focused on political advertisement and how platforms amplify and moderate distribution of ads. And another work also from the last year used even 100,000 bots to simulate this behavior. So that like representation or that objectiveness of this audit is becoming much better as it was before. And this one was very interesting. It studied how recommendation is aligned to user ideology and whether like the more and more filter bubbles are created around the user because users are recommended with a content that is heavily aligned with their ideology and some kind of expectation. And this was done on YouTube as well. So you can see that progress during the time was like really quite quick and in a very short time. And these external audits now like really represent like a mean how to objectively get information that is typically hidden from us. In this second part of my presentation, I would like to show you how such audit can be done in more details. And as example case, I selected our own audit of misinformation filter bubbles on YouTube. As you saw at the previous slides, YouTube is quite often audited because there is like at one side, we don't know much information about the e-commerce systems on YouTube. At the same time, there are strong biases towards like misinformative content or polarizing content. So YouTube is like quite often used as the case of many audits so far. So we started with audit question, and while many previous works already showed that YouTube and also others AI-based algorithms can enclose users into filter bubbles, especially what we call misinformation filter bubbles. So users are enclosed or recommended the content that promotes some specific kind of misinformation. We ask a different question, and we ask whether a user can break such bubble. So if he or she will decide, okay, I want to leave that bubble, or maybe somebody can encourage users to leave a bubble, if it is even possible. So we want to get from this misinformation state to a state where a user is presented with a more diverse set of recommended items. And our basic idea was to start watching debunking videos, so videos that actually debunk the original misinformation that was recommended to a user. And we had also a second additional research question, and we were interested whether the situation with YouTube recommender systems actually improved compared to the reference study that was done 1.5 years before our audit. And the motivation here was that YouTube actually like promised that they improve their AI-based algorithms and recommender systems. So we were interested how it actually reflected in practice. And so we compared the results between these two studies. To create audit scenarios, we created like them manually, and they consist of multiple steps. So in each audit scenario, at first we initialized the bot. This bot set up the browser with ad blocker, logged to YouTube, accepted all cookies, so it appeared like an ordinary user. And in the first phase, we tried to create a misinformation filter bubble. So we selected for multiple topics 40 promoting videos that actually contain a misinformation. With this bot, we watched each of these videos. We saved recommendations that appear on the side of a video, like next video recommendations. We visited the homepage and saved recommendations from the homepage. And we also visited a search engine, executed 5 queries that relate to the topic of that video, and save search results as well. In the next phase, we did exactly the same process, but this time a bot was watching debunking videos. And at the end, we just clean up everything. So we deleted the user history, and we cleaned all cookies, etc. So the same bot and the same user account can be used again for the next round of auditing. So during the audit execution, we selected 5 topics. These topics are actually influenced by the reference study we compared with, so we adopted them. But they are basically the main typical misinformation topics that are like provably false, and there are quite a lot of content on this topic on YouTube. At the same time, you can see that these ones should be already covered because these are no like new disinformation topics. They are like present here for many years. So probably AI algorithms already should be aware that something like in these topics can be potentially a false information. And for each topic, we used 10 different bots in the same time, so to mitigate any like content changes in time. So we do these audits in parallel. And we collected quite a lot of like thousands and thousands of videos as well. And we manually annotated 3,000 of them, what took us literally hundreds of person hours. And based on these manual annotations, we finally trained a machine learning classification model that was used to annotate videos from homepage. Because homepage is changing videos quite often, and it wouldn't be feasible to manually annotate all of them. So in this case, we opted for automatic predictions that are, however, enough reliable.
Sorry, I have a question. When you say burst misinformation bubble, what criteria did you use to decide that some content is capable of bursting a particular misinformation bubble?
Okay, so one question is how we determine whether a user is or is not in a misinformation filter bubble. So we argue in this research, also in papers, that it's not a binary state; it's more a scale from like 0 to 1. So in the next slides, I will show you the graph where you can see like the score of moving or into and outside of misinformation filter bubble, and for like how we selected that content that is used to break the misinformation filter bubble. So we particularly looked for these topics, like applied search on YouTube and also Google and other search engines, and we looked for videos that actually try to debunk it. So they are doing some kind of fact checking and providing the correct information. And if there will be some question, I will be glad to answer them as well later as well. So the first observation from this audit is that these information filter bubbles actually appear, but only in the recommendations, both in next video recommendations and also at the homepage, but not in search results. And this is something what we can expect because search results are usually not so heavily personalized as recommendations. But we confirmed the results of previous works that misinformation filter bubbles can be created at YouTube. And unfortunately, we didn't observe a significant overall change in comparison with a previous study that was done 1.5 years before. There are some improvements in some topics, but not so significant. And subtopics we didn't observe literally any significant any change at all. So this is what I mentioned before. So this is since we used a machine learning prediction, we were able to observe for the first time like a dynamics of creation of these bubbles. So if optimally, we would like to see that the like distribution or proportion of misinformation content in recommendations would be in this particular score -1. It means that there are no misinformation content at all. But you can see that for like multiple topics, it's around 0 or slightly below 0. It means that 0 value means that there is exact number of neutral and debunking content and the promoting content. And for 9/11 topic, there is even a prevalence of misinformation content in general. And we can see that for some topics, when we watch more and more promoting videos, the proportion actually didn't change. But for 9/11, the number of disinformation actually increased during the experiment. But what is very interesting, as soon as we started to watch with bots debunking videos for all these topics here, we observed this significant drop. So it's enough if a user will watch at least 1 or 2 debunking videos, like correct, truthful videos. And from that time, the distribution will improve. But watching more additional correct videos will not make a significant change. And there we can see that some number of the misinformation promoting videos is still present there. So we cannot just get rid completely of them. Improvement in 9/11 topic is not so significant here, but we can see that continuously the number of promoting videos, the proportion of promoting videos was slowly decreasing as well. So that's a good information. So yeah, we confirm that it's possible to reduce misinformation filter bubbles, and that effort requires is different for different topics. So the main contributions of this work is that for the first time, we simulated a more complex user behavior, not only promoting, but also debunking or watching a debunking content and bursting these bubbles. And we also, for the first time, replicated the previous audit. And this research was recognized also by a research community and received the best paper at Rexis conference. That is one of the best conferences in this area of recommender systems. In this last part of my lecture, I would like to continue with challenges and open problems, how this can evolve in future. So we also in our audit, and this relates also to all existing works, there are multiple challenges that prohibit like better adoption of these audits and like better interpretation and of the findings. And the first one is that these audits require quite a lot of manual tasks, especially when we need to generate these scenarios, but also to annotate the content. And therefore, we argue for like more automated audits that will make them more scalable to additional content. And the second challenge is that results can quickly become obsolete, because we know that social media platforms change their AI algorithms regularly, and also the new content appears every day. So we would like to have something else, continuous longitudinal audits, so we can like compare the results also in time. So all these two ideas were presented also at UMAP conference 2 years ago. And we acknowledge that there are also additional open problems. The one is that benchmarking AI algorithms across multiple platforms is still issue, despite we saw that there are some works already that are trying to do this, because we want to have like objective comparison of audited phenomenon on these platforms, and it's not so easy because the content is different, so we cannot simulate or do the audit with the same content. And another issue is to create authentic user profiles. So we want to mimic real interaction history, like how real users actually behave. And this is quite a difficult task together with the next one, because we want to simulate a more organic user behavior. So far, these algorithmic audits and these auditing scenarios are heavily prescribed by researchers in advance. But we would like to have like more organic behavior, so a bot can like during the audit execution time decide that, okay, now I will click on this particular result and I will follow what is recommended to me, because this simulate a more organic or more like a real user behavior. But for this, we will need some kind of model, so of how users actually behave. And I can now bridge to the previous presentation by Francesco that exactly this kind of user models and click models and user behavior models can be used here, but there haven't been used so far. But as soon as we will have such kind of model of a world, we can actually do much representative audits. Another problem is that when we are trying to audit some particular aspect, like what is the distribution of political ads for users with a different age, we need to eliminate all other confounding not to be audited factors, like the location of a user, the gender of a user, potentially like some noise in the history of this user. And this is quite complicated because we can of course simulate it like thousand users with different locations, etc. But it will significantly increase computational cost and time required to perform the audit. And therefore, the last open problem is to how to optimize audit scenarios, because all these others open problems will probably result into that we will have a huge number of auditing scenarios. So let's take this as some kind of optimization problem to select a subset of these generated algorithmic audits, auditing scenarios, and how to select a subset that will cover what we want to audit, and at the same time will eliminate all confounding factors. So to sum it up, external algorithmic audits can provide us independent and external oversight of social media behavior that is usually not achievable like in the different means that we have at our disposal, unless of course we are not working directly in social media networks. And they can reveal us what remains typically hidden from us inside the black box of these AI-based algorithms. As I showed, there are many use cases how this can be used, and political biases is one such possible topic and use case what can be like explored. And there are already many interesting results, especially from the last results that are already very large and very representative. And we argue for continuous and automatic audits that will like significantly empower these audits and provide even more useful information, like a comparison or benchmarking across multiple platforms, evolution of time, so we can evaluate whether the pledges of like promised by social media networks actually improved something. And of course, we need to do this ethically. And this is just an acknowledgement that we want to continue in this research also as a part of already mentioned Vera.ai project. Thank you very much.
Thank you very much, Ivan. That was really, really interesting and excellent work. Is there any question from the audience?
I have a question.
Yes,
So,
please.
do you account for reaction bias? So when you use a bot to sort of query on the internet, typically the internet sort of reacts in a certain way based on how many times a certain interaction happens, or so is the reaction bias studied? Like,
maybe I'm not sure if I now catch exactly what you are asking for, but if you are asking whether because we observe multiple biases, and this is exactly what we need to eliminate during the audits. One is like the bias of like takeover effect during the audit. So when we interacted, for example, with a search engine or with videos, we used during the experimentation like a sleep time. So between performing individual search queries or watching videos, we slept the scripts and slept these bots for some time. So we will not have this take over effect from one search to another one. And regarding like another bias that we observed and we wanted to eliminate is that we use in these audits like only very popular videos that have quite a lot of interactions before. So we wanted to didn't want to interact with videos that are not so like niche, not with a small amount of interactions. But I'm not sure if I answered your question actually.
sort of. Thank you.
Yeah, Richard.
Ivan, thanks so much. That was so interesting. So my question is, most of the data being generated are being generated by bots and is there a set of studies, and you mentioned as well some sort of the need for more organic data and user simulations, real user. Is there a set of studies, a similar set of studies that to the ones that you were showing that actually rely on clickstream data, or are there no such studies that where you actually have what the users have been doing on a particular platform or on multiple platforms over longer periods of time?
Yeah, so when we are talking specifically about these audits, but it doesn't necessarily need to be just this kind of audits, because there are multiple approaches. In this presentation, I was talking especially about sock puppeting audits, so we are using some kind of bots, or crowdsourced audits when we are using some users. To the best of my knowledge, there are no studies that would actually use some kind of models that or like clickstream data to make this a little bit more organic. So this is really all these auditing scenarios are really like heavily prescribed. There is one work that actually used some kind of prototypes of users. So they did a clustering of a community or something like community detection, and they selected one particular representative users from that group, and they simulated this user behavior during the audit. But I wouldn't say that this is like following of a click model or like something like that, or behavior model, because this was really just a replicating of one particular user that was somehow assumed to represent the whole community. Probably it is a better as a completely prescribed, like manually artificial behavior, but still not like the ideal solution probably we want to achieve. So in this, I am not aware of this kind of work, and in our future work we would like to examine this approach. And if we are talking like more broadly, Yeah, of course, there are in the domain of recommender systems, there are studies that actually examine recommender systems in like a more black box way. So you have a click stream models or this kind of stuff, and you want to like evaluate properties of recommendation systems, but not in this external black box online settings, but it's more like an evaluation metric of recommender systems themselves.
Thank you.
Is there any final question? No. So Ivan, again, many thanks for the very interesting talk.
Thank you very
And
much.